T1 at an angle of 45. Why? You can see the chord of the rope is height 5 feet, and the distance between the new gravity, center of gravity, and point A is 5 feet feet, so your angle is 45. Good. What else? The weight. And the weight here will be half M of the beam, because we divided the beams into half, times G. What else? $5,000? Yeah, this is weight, 5,000, okay. Okay, as a number, yeah. What else? What else? What forces we have? At a point A. Do you have a forces at a point A? Why? Because the point A wanted to move in X or in Y, but the other part he make a resistance. So we have here like EX and AY. And as you see me, EX and AY, left to right or up or down, your calculation, he will fix the sign. For example, if your AX equal 5 pound, so your assumption in positive direction, right. But if your answer is -5, he will be in the other direction. Good. And we have the moment. And the same for the other part. So what I drew now is called what? Free body diagram. So once you do your problem with external forces and moments, it is what free body diagram is.
How do you drew your moments going in the same direction? How are they supposed to go?
That's your calculation. If you calculated the moments, it's a positive, so your direction is right. If it's negative, you will be in the other direction. Right? So don't think about the direction if it's unknown. Good? How to calculate T1? Let's return to the original problem. This is T1, my friend. And of course, that is the total T. How to calculate T1? Equal why? Because the beam, whatever the point, the rope is moving up with acceleration. Good? What is that? Mass. You will see summation force in x direction, y direction equal mass times acceleration. Good? Good. So we have acceleration. Good. 0.5 to up. What about the mass? And you apply to 1 point. Do you know what's the mass of point? No, to the point, fixation point, like here. This point, what is the mass?
Is that equivalent to the entire mass? Because that is
no, there is no equivalent mass in mechanics. Zero. When to the system. Good. So summation force equal up 0. That's called point method. Any point in the system, we can consider its mass is equal to 0, summation force is equal to 0. So at any point, you can make a balance for your forces and calculate it, EX, whatever you want. Good? This is the point. We have here T. And we have here T1, the T1, which represents the tension in the other two rope. And again, what is the angle? 45. So this will be 2T1 cosine 45, and we have here T1 sine 45. So from your equations, the T is equal to T1 cosine 45. So the T1 will be T divided by 2 cosine 45. So once you know the tension in your system, divided by 2 cosine 45, you will get the tension in the other parts. Again, how to calculate T, the total T in the beam. So we calculate the internal forces at point A, and we see now the beam as a body, as a one rigid body. So this is your beam. This is T, total T, and this will be your weight. And the beam is moving up with acceleration 0.5. So here is the free body diagram of the total beam, and here is the kinetic diagram of the beam. According to Newton, summation force in y direction is equal what? M beam, the total mass of the beam, times what? A. Good. A, how much A? Is 0.5. And how much mass? 310.559. And as you like, take the up is a positive, take down is a positive as you like. But once you determine which one is a positive, it consists to the end of the problem. Good? I will take up is a positive. So will be T minus W. So the T is equal the mass 300.559 times 0.5 plus W. And the W here is will be 20 times 500 pounds. So now you can calculate T, which is equal 10,155.3 pounds. And once you know T, you can calculate T1 from here. And once you have a T1, again, to principal problem which you present A here. So we have here T1, we have here half MBG, and we have EX, EY, M. To calculate M, we need to make a summation moment around A or around another point. Let's forget the requirement. Let's say the M is given, and I want to calculate EX.
Just a cosine component.
T1.
Yeah, so T1 cos theta equals theta.
Good. So first, he will make a resolution for T1 cosine 45, T1 sine 45. So now we have all forces in x and y direction. We just make a similar calculation, summation of force in x direction equal mass times acceleration in x direction, and summation of force in y direction equal mass times T1. So the problem is easy. So again, the steps: one, do free body diagram, show the forces, then angles. Second, do kinetic diagram, show acceleration. And what is given, start from it to get the required. If you have the acceleration, you get the force. If you have a force, you get acceleration. But here in the problem is a direct problem because he wanted to calculate the moment at a point A. So summation moment about A equal what? How to calculate summation moment of point A? You have the left and the right side. Good. The left side, we calculate summation moments of all forces. The right hand side, we calculate the moment of what? Of the total force. So here is the free body diagram. We have two forces, T1 cosine 45, T1 sine 45. And we have Ax, and we have Ey, and we have a weight. In the other direction, sorry, this is point A. The beam is moving up with acceleration 0.5. So, summation moment about point A, we have T1 cosine 45, have a distance, normal distance from A 1 feet. In this direction, is a negative or positive moment? As you like. If you take this as a positive, make it consist. If you take the other as a positive, make it consist. But make simple rule, counterclockwise is a positive, clockwise is a negative. So it will be negative, and the other will be other negative, T1 sine 45 times 5 feet. How to calculate moment is a simple. The perpendicular distance between the point and the force. And just make a rotation, clockwise or anti-clockwise. The weight will be counterclockwise half mg times 5 feet and plus m equal. What moment of Ax and Ay? So we calculate the moment from T1, we calculate the moment from the weight. What about Ex and Ey?
Wouldn't it be 0 because the distance is 0 from A?
That's it. When you want to calculate moment of force and this force is passing through your interest point, the moment equals 0. Good? Equal what? The kinetic moments, which is represent the moment due to the total force, which represent half m of beam times what? Times acceleration times 5. And its moment is a negative or positive? Negative or positive? To our rule, counterclockwise is a positive, clockwise is a